When the tension of the currents is very high, the magnet ordinarily used in connection with the discharger is of comparatively small value, as it is quite easy to adjust the dimensions of the circuit so that oscillation is maintained. The employment of a steady EMF in the high-frequency conversion affords some advantages over the employment of alternating EMF, as the adjustments are much simpler and the action can be easier controlled. But unfortunately one is limited by the obtainable potential difference. The winding also breaks down easily in consequence of the sparks which form between the sections of the armature or commutator when a vigorous oscillation takes place. Besides, these transformers are expensive to build. It has been found by experience that it is best to follow the plan illustrated at Met. In this arrangement, a rotating transformer G is employed to convert the low-tension direct currents into low-frequency alternating currents, preferably also of small tension. The tension of the currents is then raised in a stationary transformer, T. The secondary S of this transformer is connected to an adjustable condenser, C, which discharges through the gap or discharger DD, placed in either of the ways indicated, through the primary P of a disruptor discharge coil, the high-frequency current being obtained from the secondary S of this coil, as described on previous occasions. This will undoubtedly be found the cheapest and most convenient way of converting direct currents. The three branches of the circuit, A, represent the usual cases met in practice when alternating currents are converted. In Fig. 1(1)(b), a condenser, C, generally of large capacity, is connected to the circuit L, containing the devices L, L, M, M. The devices MM are supposed to be of high self-induction, so as to bring the frequency of the circuit more or less to that of the dynamo. In this instance, the discharger DD should best have a number of makes and breaks per second equal to twice the frequency of the dynamo. If not so, then it should have at least a number equal to a multiple or even fraction of the dynamo frequency. It should be observed, referring to IB, that the conversion to a high potential is also effected when the discharger DD, which is shown in the sketch, is omitted.